A bionic hand with multi-touch sensory feedback. That's our Techstination in this interview. I'm Fred Fishkin, and joining us from a company called Psyonic, Psyonic, is CEO and founder Dr. Aadeel Akhtar, who has led the team developing the Ability Hand. Thank you for joining us, Dr. Akhtar.
It's my pleasure to be here.
So tell us, there it is, for those of you who are watching this, tell us about the Ability Hand and how it's different from what's been out there.
Yeah, so when we started designing the Ability Hand, we had several things in mind that we wanted to address with respect to the needs of the users. And the first and foremost was that we built this hand to be super robust, right? We were hearing from so many patients and clinicians that, their like $100,000 hand was breaking all the time. And so we wanted this thing to be built to last. And so we make our fingers out of a flexible silicone and rubber. And that gives it impact resistance. So we've done push-ups on it. We've broken boards with it. Most recently, I actually arm wrestled a para-triathlete national champion who uses an Ability Hand. And unfortunately for me, he beat me. But the hand was able to withstand all the forces that arm wrestling takes. So that was huge. It's also the fastest bionic hand in the world. Users have always been complaining that their prosthetic hands have been too slow, so we wanted to make sure that it was very quick for them to control and change grips very easily. And then finally, it's the first hand on the market to give users touch feedback. And so one of our patients is a U.S. Army sergeant who lost his hand in Iraq. And when he holds his daughter's hand, he can actually feel it. And again, that's something that no other prosthetic on the market can do.
That's amazing. So tell us the story behind it, the how and why you got into this.
Yeah, so the whole idea for this really started when I was actually 7 years old. My parents are from Pakistan, and I was visiting, and that's the first time I met someone with a limb difference. And she was my age, missing her right leg and using a tree branch as a crutch, living in poverty. So that's what inspired me to go into this field. And we found that, back home in the US, we have similar issues with access to prosthetic limbs. And one of our first patients here in the US, who I mentioned, US Army Sergeant Garrett Anderson, he uses a hook on a daily basis, and we wanted to upgrade him to the 21st century. And so we've been working with him and several others, and to get to the point where we're at now, to have this Ability Hand available to patients across the entire United States and covered by Medicare.
Well, that's one of the things you've tried to bring some new affordability to this as well.
Absolutely, absolutely. And, bionic hands that have this kind of functionality where you can move all 5 fingers, they have historically not been covered by insurance companies. And usually only about 10% of them went through, whether you were in the military or if you had a workplace accident. And by getting it covered under Medicare, we've expanded that access to about 75% of patients can now afford an advanced bionic hand in the US.
Obviously, it's not an inexpensive thing to design and manufacture. Tell us about the costs involved and the work that went into this to be able to achieve this.
Yeah, and so, from the start, we wanted to design something that was not only just more robust and had more features and everything else, but would also be covered by Medicare, because we knew how big of an issue accessibility was for these types of devices. And we're able to we kind of had to think outside of the box. Like, how could we leverage technologies like 3D printing that could reduce the cost but still make them in a very robust way? And we realized that by doing things like, instead of 3D printing the hand itself, but 3D printing molds and using injectable silicone and rubber that's low cost, we could reduce our cost by a third of what our competitors use to build their devices, with them using injection molding and custom machined steel. And because of that, we were able to hit that Medicare price point.
And this is connected. Tell me about it.
Connected.
You have this has Bluetooth in it.
Yes.
And can get over the air updates. Tell me about it.
Exactly. So We have an app on both iOS and Android, and it communicates over Bluetooth to the hand. So if we have new grips or new features in the hand, we can actually upgrade it the same way you would upgrade your phone, essentially the software on your phone through an over-the-air update. We've got like I said, mentioned different grips that you can do. So here's like what we call our tickle grip, right? And so that's something that was brand new that we just developed, a couple of weeks ago. And so all of our users can just download that from their app, and then they can get that grip to use on their hand.
Truly amazing. So tell us what does it cost if someone were looking to purchase one? Obviously,
Yeah,
it's not inexpensive.
Yeah, and so depending on where your insurance goes, I mean the cost of the hand is somewhere between 10 to 20,000, but and that's usually a price point that Medicare will cover. And that was really, like I said, that was really important for us to get that Medicare coverage. To the user, though, it's whatever their copay is. So it's it could be a couple $100 out of pocket, or less than that.
So tell me about the availability, where people can go for this. Obviously, they have to be working through a facility or a doctor, correct?
Yeah, so they have to get it. It's an FDA registered medical device, so they have to get it prescribed from their physician. But they'll typically work with a clinician known as a prosthetist. They've gone through 2 years of a master's program to learn how to fit these devices to patients and develop sockets that are molded to their residual limbs. And we work with their prosthetist. So the prosthetist will design the socket, and then we will fit the hand to the socket that the prosthetist designs on the patient.
How does the feeling aspect of this work? How are you able to connect this to the brain?
Yeah, and so when we think about bending our elbow or moving our fingers, muscles in your forearm are actually still firing. So especially the ones that are moving the fingers, right? So if I lost my hand right below my elbow, then if I was trying to move my fingers or make a fist or bend my wrist, you still have those muscles activated in your forearm by your elbow. And so we can pick up on those muscle signals. So when your brain is saying, like, make a fist, then we can pick up those muscle signals in your residual limb and make the hand do the same thing. And as for the touch feedback, in the fingertips, we have 6 pressure sensors in the pinky, the index finger, and the thumb. And then when you touch those, the user will feel a vibration on their residual limb, and that will allow them to know when they've come into contact with an object, how hard they're pressing, and when they've let go of that object as well. So right now it's just a vibration, but we can actually stream all of the pressure sensor data over Bluetooth and detect exactly where you are pressing. And we have some collaborators who are doing brain implants, for example, and they can stimulate areas of your brain that correspond to where you touched on the prosthetic hand, and it'll feel like it's coming from their phantom limb.
Wow. So obviously this is getting better all the time. And where else do you want to take this? How much better can this get? And are there other things you're working on?
Yeah, and so where this field is definitely heading towards is more seamless integration with the human body and going invasive, right? So we're talking about like brain implants, spinal cord implants, connecting directly to the muscles, integrating these prosthetics with your bones. And we designed our hand to be ready for those systems when they come out, so that when we get implanted electrodes that FDA approved and they're out in the market, that our hand will already be ready to work with those systems. So that's one of the areas that we're looking into. But also the same technology that we have in our hand for controlling our fingers are directly applicable to elbows, knees, and ankles as well. So we're already thinking about ideas on an ability leg in addition to an ability hand.
Very, very exciting. For more information, where's the best place for people to go?
So they can check out our website at www.psyonic.io. And we're also on all social media channels. We just released that arm wrestling video with the pair triathlete on YouTube. So I would love for everyone to check that out and give us a like and a subscribe.
That's awesome. And we should say that this came out of work through the University of Illinois at Urbana-Champaign. Is that correct?
That is absolutely correct. And that's where I did my PhD in neuroscience there. and a master's in electrical and computer engineering. And this is kind of the combination of all those different fields. And so it was started as a PhD project, and then we spun it off and turned it into a company to help as many people as possible.
Again, the website is Psyonic, Psyonic.io. Dr. Aadeel Akhtar, thank you so much for taking the time with us.
Thank you. Take care.
Now this. It takes a lot of listening to build a better radio, and that's just what the folks at C. Crane have done. Bob Crane and his crew, nestled among the rivers and tallest trees in the world in Fortuna, California, have made a habit of listening to their customers. And that's just what they've done in building the CC Skywave SSB, the Swiss Army knife of portable radios. For everyday listening to AM or FM in the yard or patio or on the nightstand, without having to drain a mobile phone battery, it's a great companion. But it is also a companion equipped for NOAA weather information and alerts that can be life-saving. You can listen to FEMA and Coast Guard transmissions too. Beyond all of that, you can tune into shortwave signals from around the world. It's compact, easy to take with you, and built to last. The CC Skywave SSB. Click on the link at Techstination.com.